Okay. So regarding sequences in series, we have an important test called ratio test. What this test says like is if there's a positive series, if I have a series of positive terms, then it says that summation un. Sum of positive series would be called as summation un. If I have a positive series, then the ratio of its nth term by n plus one term value as n tends to infinity, if it comes out to be L, and if L greater than 0, the series would be convergent, and for L less than 1, the series would be divergent. There are different logics behind it, why the condition is like that. But first of all, let us look into the test, how to test this and how to work out with the ratio test, especially for engineering mathematics. And for the exam sake, let's see how to work out with this test. Okay. Now, the third point, I have just left it open because if L turns out to be 1, if L is equal to 1, this test fails. That means what? This test fails. That means what? We need further investigation, or we need to use some other test to check whether the series is converging or diverging. Basically, convergence means tending to a finite value. Diverging means tending to an infinite value. Okay. So converging is what we are more interested in a converging series than a divergent series. Okay. I've considered an example, an easy example, by the way. Let's do one more, a bit tougher one in the next case. But as of now, let's do with this easy example where the nth term is directly being given. So I'll start solving it. First thing is, because I'm talking about the series to be in terms of summation un, I'm just considering the given series to be summation un. Let summation un is equal to, because it's easy for me to handle un and un plus 1 terms. If I give it some notation, okay, 3 and so on till n as the numerator, 3, 5, 7 and so on till 2n plus 1 is the denominator. Now, how do I get the, what would be the next term? How do I get it? You can use AP, guys, AP in the numerator and the denominator, where for the numerator here, AP, the first term would be 1 and the difference d would be 1. Okay. So I'll construct the nth term. Nth term would be like this. 1 plus n minus 1 into d is 1, right? So 1 plus n minus 1. So minus 1 and plus 1 cancels, and then this is how I'll get 1. For this denominator, just see. Again, I'll use a formula for AP. The first term, A is what? 3. D is what? 5 minus 3, 7 minus 5 would be 2. So the nth term would be something like A plus n minus 1 into D. N minus 1 into D is 2. So I'll be having 3 plus 2n minus 2, which would be 2n plus 1. I think it's clear to all of you. Okay. So that's how I'm getting the nth term. But this doesn't mean that I just need the nth term. Nth term has all the terms in the series. All the n terms in the all the n terms. The nth term has all the n terms. The first term has one term, second term has two terms, third term has three terms, and all the things. Okay, I will talk about it a little later. I mean, first let me show you how I'll be applying ratio test. Okay, then talk about the different things and the logic behind it. Okay. Yes. So for the ratio test, I'll be needing the nth term and the n plus 1 term. So the n plus 1 term would look something like this. Un. Un is this. So un plus 1. If I remove summation on both sides, then it would be the nth term. Okay, if summation is there, then is the sum of the series. Okay. 1 into 2 into 3 into and so on, n into n plus 1 would be added on. Okay. 3 into 5 into 7 into so on, n plus 1. See the n plus 1 term. I'm sorry, 2n plus 1. So 2 into n plus 1 plus 1. So it would be what? 2n plus 2 plus 1 would be 2 plus 1. It would be 3. Okay. So accordingly, I'll be writing. Okay. 2n plus 3 is what I'll be having. Okay. Yes. Now for the ratio test, I should be consider un by un plus 1 ratio. Okay. So I'll be having what? 1 into 2 into 3 and so on till n by 3 into 5 into 7 and so on till 2n plus 1 into 3 into 5 into 7 and so on till 2n plus 1 into 2n plus 3 by ulta, because denominator by denominator goes to the numerator. Okay. Yes. So 1 into 2 into 3 and so on, n into n plus 1. Now you see, small simple logic. If I have 3 factorial by 2 factorial, then it is what? 3 factorial can be written as 3 into 2 factorial by 2 factorial. So 2 factorial and 2 factorial gets cancelled off. Similarly here, 1, 2, 3 and so on till n is n factorial. Till then it gets cancelled. N plus 1 term will be remaining here. 3, 5, 7 into 2n plus 1. The 2n plus 1 factorial gets cancelled off and 2n plus 3 will be remaining. Okay. So I'll be having things like this. That's what? 2n plus 3 by n plus 1. What am I supposed to be doing according to the test? I'm supposed to be applying for the nth term by the n plus 1 term ratio. Mind you guys, there should be no summation. If summation is there, that means it is the sum of the series and then you cannot apply any limit or anything as per your interest. Okay. If it's an nth term, I can handle it in my own way. Okay. So for the nth term, I should be substituting the limit n tending to infinity. u1 by u1 plus 1. Now if I put infinity here and here, then it would be infinity by infinity form. So I'll be taking out n common in both the terms. As n tends to infinity, I'll be taking out n outside. I'll be taking n outside. Okay. So n into 2 plus 3 by n by n into 1 plus 1 by n. Because if I put, it will be infinity by infinity form and I have to be using L'Hospital's rule. Okay. So as n tends to infinity, what happens? 2 plus 3 by n goes to 0. 1 plus 1 by n goes to 0. I'll just write here limit n tending to infinity 1 by n, or limit n tending to infinity 2 by n, or anything by n goes to 0. Okay. So this value would give me 2. Now please tell me, according to the conditions of the ratio test, the value that I've got is L. If L is greater than 1, the series would be convergent. Okay? Yes. This value is L and it is greater than 1. Hence, what I will write? Summation un is convergent. That's it. You don't need to write anything about the test. Is convergent by, it's actually called D'Alembert's ratio test. Okay. D apostrophe Alembert's ratio test. Summation un is convergent by D'Alembert's ratio test is the conclusion that you will make. What you will write here, this is equal to 2. 2 value is equal to L. L is greater than 1. Okay. Hence the given positive series converges by D'Alembert's ratio test. That's how you will conclude or do a problem on D'Alembert's ratio test. I'll discuss one more example on a ratio test, guys. In short, it is called D'Alembert's. In short, it is called ratio test. Otherwise, it is D'Alembert's ratio test. Okay.